screen next to me. So what is version control? Well, version control is something which is designed to try and solve this problem, which I suspect at some point we have all had, which is this notion that you have written some sort of document, made some sort of file, and you regard it as final. You then take it to your supervisor, to somebody to look at. They give you some revisions. You end up with this document, final, and then Rev 2. And it keeps going through all of these different processes. You end up exchanging emails with somebody who's made changes to the document, and you end up with 16 different versions of the document, all with increasingly difficult to follow names. Even if you have some sort of sensible naming convention for this, it's hardly flawless. It's possible to overwrite a previous version of the file accidentally, and things like this. So for anybody who isn't familiar with PhD comics, given that I suspect most of you are either PhD students or postdocs, I heartily recommend visiting phdcomics.com. There are many insightful comics from that collection to, I suspect, all of our lives. So um, so what version control does is it effectively adds an extra layer onto the file system which you've got on your machine. So your file system separates files up into different directories, folders, and locations across the file system. Um, if But it adds, in addition to that, effectively a dimension of time. So you are able to look back over the document as it has developed over time, and see changes which have been made, keep track of the changes over time, and indeed revert back to a previous state of the document if that's appropriate. Um, yeah, as the notes say, you can think about this, about the changes being something which are separate from the document itself, and which knowledge of those changes allows you to play back the document or the file to the state that it is in at some given point in time. Likewise, as well as changes over time, if two different people make changes to the file, in a similar way, you can keep track of those changes between which two different people have made. Look at the state of the file after the changes have been made by both people, and indeed combine those changes either automatically, which Git is able to do in some cases, or walk through and consolidate the two files which contain changes made between two collaborators. So obviously, if you're writing a paper with somebody, they may work on one section of the paper, you work on another section, and you want to bring both of these together and merge them at some point. That is a scenario in which Git is particularly helpful. Likewise, if you're writing code and two of you are working to fix bugs in different parts of the code or add new features, you'll want at some point to consolidate these and bring them all together. So Git is able to do all of these things, and it has lots of extra helpful features, which we should hopefully manage to cover, even if slightly briefly, to assist with this whole process and organizing all of it. So while we'll be talking exclusively about Git today, there are other version control systems are available. Amongst the modern version control systems which you're likely to come across, Git is by far the most popular. There's another one called Mercurial, which is written entirely in Python, and which grew out of the Python project itself, which is broadly similar to Git, but it has some differences in how it works. If you understand Git, you will be able to pick up Mercurial quite quickly. It's slightly simpler than Git. There are older tools like CVS and Subversion, so some of you may encounter these at various points if you are working, for example, with older code which hasn't been moved across to Git. They're broadly similar. They work in a slightly different way, and you will probably have to go and learn some slightly different concepts about how they work, although the general overarching idea of what they do is nevertheless more or less the same. So Git and Mercurial are a little bit different from these, though, because they're designed to be distributed version control systems. So There is no single central source of truth for these repositories, so lots of people can have copies of the repositories and they can all be brought together to consolidate them, whereas generally CVS, things like CVS and Subversion, there is one central source of truth, which everybody has a copy of and pushes things back to. Don't worry too much about what that means at the moment. If you encounter it at some point, hopefully you will be able to figure it out from what you understand again. So there's a little question here. I'm going to skip over it so that we can get on to the actual meat of the lessons. So let's start out by getting set up. So if this is the first time which you've used Git, which I imagine for some of you it will be, we need to do a little bit of very initial setup. So Git needs to, so that Git, when we're working with other people, is able to assign your the changes which you make to you as opposed to somebody else. It needs a little bit of information about yourself. And it does this through its built-in configuration. Now, Git commands all look relatively similar, which is that they start with the word Git, and then the next word is some sort of verb which describes what you want Git to do. So in this case, you want to configure Git, so you say git config. And then what goes after this are just the sets of options. So for git config, I'm going to set up and tell it that I want to tell it my username, my name, and my email address. Now, because I will never remember to reset this later on, I am not, in fact, going to claim myself to be Vlad Dracula. Now, I apologize right now. This software carpentry lesson goes into some levels of slightly ridiculous whimsy about Dracula and various other things. Just bear with me. It gets a bit over the top, I think, at various points. So you will need to, first of all, probably make a directory where you want to set everything up. So that can just be inside your home directory. So if you're in your home directory as default, you could make a directory called git lesson and cd into git lesson. So then, oh, sorry, I probably should not have cleared the screen there, but I will try and avoid doing that. So git config, so global just tells Git that I want to set this as my username for all of the repositories. So every situation where I'll be using Git by default, I want to use this. So user.name, and I want Daniel Williams. And likewise, git config global user.email. I want And I recommend when you're doing this, for the same reason that I'm using my own name and my own email address, that you use your email address and your name, because again, you will probably forget to change this, and then at some point you will push to a repository, and somebody is going to be extremely confused when you have claimed to be Dracula while making your commit. So there is some discussion here about dealing with different kinds of line endings. I suspect nobody's going to need to worry about this. If you start noticing something weird going on with during the lesson where it looks like line endings are getting confused, we can try and fix this. But for now, I'm just going to skip through this. There's some discussion here about how you can set your default editor in Git as well. So do feel free to come back and have a look at this once you're a bit more comfortable with what we're doing. For now, I will set things up just I suggest that we just leave things using your default editor, but you could change it if you You could change it if you want to very specifically use the nano editor, if that's what you're comfortable with after last week's session. So this is the next thing which they talk about in the notes is about default Git branch naming. So in the last couple of years, most websites like GitHub have started by default calling what's called the main branch in Git, so the place where your code or your files live by default, have started being called main. Now, this will make more sense when we get to it later on in the sessions. In the past, this was by default called master, but the community has generally started trying to move away from using terms such as master and other inappropriate terminology. So you can now also change the name of the default branch to main in Git. Now, if you have a version of Git after 2.28, if you have a version after 2.28, then you will have this set by default. If it is prior to 2.28, which I think mine is, oh no, mine is also that now. So if you have a version prior to 2.28, you'll need to set init.default branch. In the same way as you set user.email and user.name, you'll need to set that to main or whatever you want to call it. All right. Let's not worry about things like proxy URLs. That might be something which you will need at some point, but again, it will become evident if you do, and one of the demonstrations can help you out. Otherwise, you can revisit this later on. So we've had a look at the git config command and using this --global. You can't see to the bottom of my screen, that's interesting. This --global flag to set global properties. Okay, so now we can get started on actually making what's called a repository in Git. So a repository is just a directory in the file system which Git is specifically monitoring the history of. So Git's now configured and we can start onto this slightly strange narrative which the software carpentry lessons have to frame the whole setup of what we're going to be doing with Git. So they are telling us a story about Wolfman, Dracula, and how they're investigating sending a planetary lander to Mars. So all totally relatable things for most of us, I'm sure. So we get started by making a directory. So if we are in so they set it up on your desktop. Not all Linux distributions will have a directory already called desktop. So, and I wouldn't myself keep repositories there. For what it's worth, I have a directory in my home directory called repositories where I tend to keep these. But for the purposes of this lesson, we can work with. So make dear git lesson is just where I'm going to keep this. So I made this earlier, so this is going to throw an, oh, sorry. Made this earlier, so this is going to throw an error, but I can cd into it. Oh, also, I appreciate, compared to Norman, I have a very weird looking prompt. So this chevron thing in my prompt is the equivalent to the $sign that he will have had in his. So it's just telling me where the prompt starts. I've just got some extra stuff here to make it so that I can see where I'm working in the terminal at any given point, and it will also show some information about the Git repository once we get started. Okay, so once you've got a directory where you want to work, then we can turn it into a Git repository by running the command git init, init, so init for initialize. Okay, so this will write out some information to the screen. So this is just telling me that it has inherited some old configuration on my computer from previous versions of Git, which mean that I'm still calling things master when I start, which I should update at some point, but now is not the time to do it. But yours may not have this if you are working for the first time. And then it'll tell you that it's initialized an empty Git repository in this location. So it'll tell you that it's produced this .git directory, and that .git directory is important because it's where Git stores all of the history. So you will, because it starts with a period, a full stop, you'll notice that that means that it is hidden. So if I run ls in this directory, it still looks empty, but if I run ls -a, you can see that this .git directory now exists. So it is important that you look after this .git directory because this is the thing which stores all of the history of what's in the directory. Now, if you do attempt to remove it accidentally, it should warn you. Oh, it does not warn you anything at the moment. So removing that makes this directory cease to be a repository. Once you've started making changes to what's in the repository and starting to run things through Git, it will tell you that some of the files are write protected, but you should avoid at all costs deleting this .git file. So I'll just run git init again, like this. Okay, so because my default branch was not called main, the lesson is going to tell us how to make it into main. So I can run git checkout -b main. So this checkout command changes what we call the branch in Git. So the branch is basically when we have the history of what's going on in this directory, it can be split into lots of timeline. It effectively runs along a timeline. And we can split this timeline so that we can go and edit one file for, say, I've got some project where I want to work on some part of the file or what's in the repository, but I don't want to change the state of the code that I'm sending to other people. So I want to split this timeline off so that I can work on it in sort of a compartmentalized way. So that's what a branch is for. And as I said before, by default, all of these things go onto this master branch. And we've just changed to make, so this checkout command is what you use to change to a different branch. By giving checkout -b, it's just a quick shortcut to make a new branch called this thing, and I want to call it main. And then, so what this does is it makes the branch main and then changes to it. Then if I run git status, so the git status command will tell us about what is actually going on in the repository. It tells us that we're on branch main. There are no commits. So a commit is the point at which the point at which the directory has been frozen in time. So we've made a specific snapshot of the repository of the directory at that time and committed it to the repository. So there are none of these snapshots, no commits so far. And then Git tells us there's also nothing to commit. So that means that there are no changes which are waiting to be added to one of these commits, one of these snapshots. So it says you need to create or copy some files in and then run the command git add to start tracking them. So we will talk about what that means shortly, but this just running git status at the moment just tells us that we have a repository which is currently doing nothing. We'll come back to git status though many times as we run through the lessons, as we run through the different chapters of this lesson. Okay, so the notes have so a little bit of side information here about different places that you can go about making Git repositories and about setting up multiple Git repositories in different locations. I'm just going to skip over this for the moment. We can come back to this. It's basically just giving you an opportunity to try out running Git init a few different times. But they do have a question. So Wolfman explains to Dracula how a nested repository is redundant. So in this previous section, he's made multiple Git repositories within a Git repository. Now, there are occasionally situations where you do want this, but we're not going to talk about them today. But normally that is a redundant thing, so you can keep directories, subdirectories inside your repository. So what do you need to do to remove a Git repository? And the answer to that is, as I've already shown you, is to remove the .git directory. And that's why it says here that the solution is to be used with caution. So yeah, you rm the .git directory from whichever directory you want to cease being a repository. Okay, so now that we've got our repository, how do we go about recording changes using Git? And how do you check the status of those changes and of the files in the repository? And how do you go about making notes about what those changes are? So that's what we'll talk about in this section, where we start to actually make these commits, make these snapshots in the repository. So assuming that we're in our repository, so I'm in my Git lesson repository just here. Let's start out by making a text file, which I want to keep some notes in, and then I want to keep track of those notes in version control. So this whole narrative in this lesson is about going to the planet Mars. So let's make some notes about the planet Mars. So I'm just going to open Nano text editor to make this mars.txt file. And I'm going to say it's cold and dry, but everything is my, I can't type this morning. But everything is my favorite color. And I'm just going to save that. So if I run ls, you can see that there's now this file called mars.txt. And it contains this cold and dry, but everything is my favorite color. Okay, so now what happens if I run git status? So I get told that there are no commits and that we're on a branch main, but this time it tells me that there's an untracked file. So there's a file in this directory which Git doesn't know anything about except that it exists. And that's this mars.txt file. Otherwise, nothing's been added to the next snapshot, the next commit, but this file is still present, is what it's telling us. So, and you'll also notice in my prompt that this is the reason why there's this question mark, which is doing the same thing. At the end, if anybody's curious about what this prompt is, I can remind myself of what the software package which does it's called and let you know. It's kind of useful. But we've got this untracked file. So how do we tell Git to start tracking it? Well, we run this command git add mars.txt. Okay, So now Git is going to has prepared to add Mars to the next snapshot that we make. So if I run git status, it now shows no commits yet, but the next changes to be committed come from this new file, mars.txt. Okay, I've talked a lot about preparing the snapshot. Let's actually make it. So git commit so git commit is the thing which will make this snapshot. However, we should always add a note to the commit to explain what we actually changed in very brief terms. So git commit -m for message. Start notes on Mars as a base. And I hit enter and run this. My screen went weird and I had to enter a password for this. I will explain later if anybody's curious why that was, and it shouldn't happen again. But it's just something to do with how my Git is set up. That probably will not happen for you. Okay, so Git, the commit gets made. It tells me that it was made to main. Start notes on Mars as a base. One file was changed, and that change was an insertion. So a new file was added. And this file was created. Mode 100644 is just to do with permissions of the file and some other settings which are specific to Linux. You don't need to worry about this really. And then that file was mars.txt. Okay, so everything about that file has now been permanently stored within the repository. So we will always be able to go back to the file in its current state. That has been added in its current form as an irreversible, as a permanent snapshot. So when I added this message, it's always a good idea to make this message kind of short and just easy to follow. So start notes on Mars as a base is something which is kind of clear. You might want to add a little bit more or less than that, depending what you're working on. It is possible to add much longer commit messages. The first line of it should always be short and concise, and you can add much more detail in further lines. So if you run git commit without the -m command, it will instead open an editor to allow you to write a much longer commit message. The notes here at this point tell you that good commit messages start with this brief statement, which is true. There are different conventions for writing commit messages, which you may or may not want to go look up. I think if you, the link in the notes will probably take you, to a web page which discusses different conventions for how you should write these. It can sometimes be very useful to have much more detail in your commit message after the first line, if you are doing something particularly complicated, or you're working with lots of other people and they need to understand exactly what you've done. So these commit messages don't have an upper limit in length, but the first line should be short and concise. Okay, so if I run git status now, I get told I'm on the branch main, but there's nothing to commit. And now it says working tree is clean. So working tree clean just means that there's nothing in the directory which hasn't been added to the Git repository, and there are no changes in it which have not or do not exist in the most recent snapshot, in the most recent commit. So what I will see when I look at the repository is exactly the same as what was stored in the most recent snapshot. Okay, so say I want to understand what's happened to the repository in the past, what we've done so far. Obviously for this repository that's going to be not very much, but we can run the command git log. I get told quite a lot of information here, but you can see the commit message, so this start notes on Mars as a base is here. And it's attached to this stuff, and it tells me, well, I ran this on a given date, and it was Daniel Williams, me, who produced it, and my email address. And then there's this thing, and it tells me this thing is a commit. And then there's this massive string of numbers and letters. And this is, in fact, a hexadecimal number, which describes the commit and it uniquely describes the commit. So this is generated cryptographically from the contents of the commit, so the contents of the changes. We will talk a little bit more about what these are for as we go through. And then it just tells me that head, which is the current location, the current view of the repository, so the snapshot the repository is currently set at, is set here at this commit on the branch main. So again, this is a lot of information. If some things didn't make total sense at the moment, that is probably fine. They will start to make more sense as we see more things going through. But you can see in this log, we have one item of history, which is this one single commit, this snapshot about starting notes on Mars as a base. Okay, so now it's time to move on to making some changes to this file. So say I decide to add some extra text to the file. So I'll open it again in nano, mars.txt. I want to add a second line to this and say that the two moons might be a problem. I'll save this. I'll run git status. I'll git status, and this time it tells me working directory is no longer clean. There are things in the working directory which I need to deal with. So there are changes which are not currently staged for the commit. So that means that there are I've made changes, but I've not told Git that I want to add those changes to the next snapshot. So Git does this thing where it has its previous snapshot, and then it has a thing called the stage where it starts to work on the next snapshot. Don't worry too much about what this means. This is a little bit different from how some other version control systems do things, in that you can add some of the changes which you have made. So you can edit multiple files and only add some of them to the next snapshot. There are reasons why you may want to do this under certain circumstances, which is why Git allows you to do it, but it does make things very slightly more complicated to follow. But this is what Git is talking about when it's talking about the stage, is that it is what it's preparing for the next snapshot. And nothing has been added to this staging area yet. To add this into and we can have a quick look before we do anything else at what the differences between what's in the directory currently are and the previous snapshot by running git diff. So diff for difference. And you can see it gives you a whole pile of information here, but basically what is important is this thing which is after the plus sign, which is telling us that there is this addition of two moons might be a problem for Wolfman. Okay, so now we want to start to prepare the next commit. So again, we add the changed file, this mars.txt, to the stage with git add mars.txt. And now we need to make the new snapshot, the new commit. Git commit -m added concerns about effect of moons on Wolfman. Okay, so now if I run git status, I get told there's nothing to commit and the working directory is clean. So everything has been added as we expect. And git log, we can now see that we have these two commits and that head, which is the current status of the repository, is at this new commit. So this added concerns about the effect of wounds on Wolfman. Okay, now let's say we want to make yet another change. This time we want to think about the effects that Mars is going to have on the mummy which they're taking with them. So nano mars.txt so the mummy will appreciate the lack of humidity. Okay, and I want to make the next snapshot the next commit. I'm going to try and start calling these things commits, because whilst they are effectively snapshots, the correct terminology for it in Git is really to call it a commit. So I want to make this commit, so I go git commit -m added note about mummy. I'll run this, I get told no changes added to the commit. And of course you can see what I've forgotten to do. I've forgotten to add the changed mars.txt file to the staging area. So to get around this, we need to remember first of all to run git add mars.txt after we make the changes, and then we can run the git commit command. Likewise, if I wanted to, so I previously showed you how you could run git diff to show the differences between what is in the current working state of the repository directory and what's committed to the repository. I can also run git diff staged if I want to see what the difference between the previous commit and what is sitting in the staging area is. I'm not going to run that at the moment because there's nothing in the staging area, but that is how you would go about checking the difference between files which you'd run git add on and files which are in the previous git commit. Okay, and if we run git log now, we'll see that once again we have added to the entire git log, and things are starting to get we're now starting to develop a more comprehensive history of what's going on here. So there's some notes. Again, I do recommend taking a bit of time to look over these notes again later on, because there are lots of things which I'm going to kind of skip over, including some details about how you deal with the log once it gets sizable, how you limit it to just a small number of the most recent entries, and some other things about how you work with diffs between things which are, for example, text documents. Equally, there are some weird oddities about how Git deals with empty directories, particularly which are discussed in this yellow box here. And again, I'm going to skip through this because No, I'll talk about this very briefly. I think this is actually moderately important. So say we want to add some notes about different ways which we might get to Mars. So say I want to make a directory called spaceships, within my repository, and I can run git status, and it still claims that the working directory is clean despite me having made this new directory, which might seem a bit strange because if I... Oh, yeah, thank you. So it still claims that the working directory is clean despite me having added this new directory, which might seem a bit strange. Equally, if I try to add it to the staging area, git add spaceships, and run git status, nothing seems to have happened. So that's because Git by default ignores empty directories. The workaround for this is to add a file called git keep to an empty directory to make sure that it gets kept in the repository. So I can just run touch to make an empty file of spaceship/.getKeep. Now you can see that git status tells us that there is this empty directory which we need to add. And you can run git add spaceships. Git add spaceships directory. That is basically how we deal with directories. If you have files sitting in the directory, you can just add the files to the repository and Git will automatically add the directory which those files are sitting in as well. So you can go, so again, they've got this example of adding a spaceship to this Apollo 11 spaceships directory. And you can just, and therefore you can just add these things and run your commit for your initial thoughts on spaceships. Okay, so I'm not going to try and get you all to do a show of hands or anything. We would probably do that if we were in person, but I will just talk through this question about choosing a commit message. So which of the following commit messages would be most appropriate for the last commit made to Mars.txt? The first option it gives is just changes. The second option is added line, but the mummy will appreciate the lack of humidity to Mars.txt. And the third line is discuss effects of Mars's climate on the mummy. So the first one, changes, isn't really particularly helpful because we know that whatever is in a commit are going to be changes of some kind. So this is a bad option. The second one is added line, but the mummy will appreciate the lack of, etc. is also bad because we can see by examining the commit in more detail exactly what it does. So writing out in English exactly what the commit does is unhelpful. But this discuss effects of Mars's climate on the mummy is more useful because when we look at the Git log, we can see in the Git log that this is a nice, concise description of what we've changed. So yeah, and that's basically what they say. It's short, descriptive, and it is imperative as well, which I guess is saying the same thing. So again, which command below would save changes of myfile.txt to the local repository? So the first option here is git commit -m my recent changes. So the next one is git init my file, and then the git commit, git add my file, git commit, and just git commit -m myfile.txt, my etc. So the first one, we saw what happens if you do this, if you just run the git commit with no changes. There's going to be nothing in the staging area, so this commit will fail. Git init is used to start a new repository and not to add files to a repository, so this is going to throw you an error as well and tell you that you've already initialized a repository, and then the commit will fail because nothing will have been added to the stage. 4, this git commit -m myfile.txt is going to run into some weird error, I suspect, in that it's going to attempt to add myfile.txt as the commit message rather than my recent changes as the commit message. The correct one is, in fact, this git add myfile.txt to add the myfile.txt file to the stage, and then git commit and -m with a message to forge that commit. Then there's a question. Staging area can hold changes from any number of files that you want to commit into a single snapshot. So say you, for example, added some text into mars.txt and you wanted to create a new file called venus.txt, which has got some initial thoughts about the potential of using Venus rather than Mars. So if you want to add both of those to the staging area, as you might imagine, you can either run git add mars.txt, git add venus.txt, or you can run git add mars.txt, venus.txt in a single line. So there's, which is the solution which they give here. Okay, so there's one final little exercise here which I will leave for yourselves, which is making a new Git repository with a biography of yourself, and you can to give you a chance to play around with something very basically the same as what we've done in the examples so far in this section. So so far in this section we've covered using this git status command to see the current status of a repository, about how files stored in the directory are different from the files which are stored in snapshots and different from the files which are organized into the staging area, how we use git add to add files from the current working directory into the staging area, and then how git commit takes everything which is in the staging area to produce this commit, this snapshot of the current state of the directory. Okay, so I'll talk through this exploring history section, and then at the end of this I suggest that we take a short break so that everyone can get something to drink and stretch their legs. But I think this shouldn't take too long, hopefully. So now that we've got all of these different potentially these different files with their history and various different snapshots, how do we go through looking at these different snapshots? How do we identify where the old versions of these files are? How do you look at the changes which have been made to the files over time? And how can you go back and recover an old version of a file if, for example, you do something catastrophically daft and you make a commit which has accidentally removed 3/4 of your thesis? How do you go back and undo that? Well, fortunately, version control allows you to do exactly that kind of thing, which might be kind of catastrophic under other circumstances. So up until now, we've been adding one line at a time to this mars.txt file, so it's been quite easy to see what's been going on in terms of our progress in the repository. So let's, for example, right now have a look at the contents of mars.txt. So right now it's got these 3 lines. Let's add another line to it. So an ill-considered change is what they suggest adding. So if we then run git, so first of all, if we run git diff, we'll see that we've added this an ill-considered change line. If we write something, so if we write git diff head mars.txt, we should see the same thing, because git diff is just a shortcut for this same thing. In effect, so git diff head tells us specifically that we want to look at the difference between files in the working directory in their current state and in head at the status head, which is the most recent snapshot, the most recent commit in that repository. So I run git diff head, and then I specifically just want to look at mars.txt. So git diff head mars.txt. Now say I want to see what's changed over a longer period of time. So say I want to look at how mars.txt has changed since not the most recent commit, but since the one before that. I can run git diff head minus, so git uses this tilde sign to represent a minus in this context. So tilde 1 mars.txt. Okay, so that is taking us back to and we can look then at, sorry, yeah, head minus 2 is what we need to go to get to. So head minus 1 is just head. Head minus 2 gives us the one before that, and head minus 3 shows the number of changes which have been made since, in this case, the very first commit, so 3 back. Likewise, we could use the command git show, which will show us a little bit more detail about what has changed over that period. So we can see which commits have actually gone into this. Okay, so it's all very well using this minus syntax, so to look at 3 commits earlier. But what if we want to look at the difference between a specific commit at some point in the history without wanting to count backwards like this and the current state? So we can run, so if we have a look at git log, so remember I said that these lengthy numbers represent a unique identifier for the commit. Well, we can now use those to refer to any individual commit that we want to work with. Normally, these are 40 characters long, I think, which is kind of difficult to deal with. Ordinarily, you can work just with the beginning of these. Now, this is not guaranteed to be flawless, but in most repositories, it is highly unlikely that there will be a duplication of the first few characters. So say 7 or 8 characters. It's very unlikely that there will be a duplication of these first set of characters because of the way that these things are produced. These are called hashes. And the way that they're produced means that it is highly unlikely that there will be duplication between these. So if I just copy the first, well, I've taken the first 8 characters there of this hash and run git diff git diff of this commit, and I want to look at mars.txt. You'll see that it shows the diff between this commit about the mummy and our current, the status of the working directory. And we can try this for all of the different commits which exist in the repository. So this is the alternative way of addressing a commit, which does not rely on us treating the history in a completely linear, backwards fashion. Okay, so if we run git status again, we can see that we've got this modified mars.txt file, which hasn't been added to, which hasn't yet been added to any commit. Say that we decided that the changes which we made are indeed ill-considered, and we don't want them to ever enter into the file itself. Well, this is the point where we can start pulling stuff from previous commits, previous snapshots of the directory. So if I want to revert this mars.txt file to how it was at the previous commit, I can run the command git checkout. So git checkout, I told you earlier, is how you change between branches. It can do a lot more than just change between branches. In fact, it's used to draw information from different parts of a repository into your current working directory. So I can run git checkout head mars.txt. Okay, so what's happened here? Let's have a look. So if we now cat mars.txt, you'll see that that line and ill considered change has disappeared. And that is because we have pulled from the head commit, so the most recent commit in the repository, we've pulled the file mars.txt, and it's been moved back into the current working directory and has overwritten the file which had the changes in it. And if we run git status, we'll see that everything is back to the way that it was at that at the state of head. So this mars.txt file is exactly the same as the one from head. So likewise, in the same way that we were able to run git diff on different commits, we can use the same git checkout head -3 mars.txt syntax, for example, to pull the state of Mars from 2 commits back. So the state is 3 commits ago. And we can keep doing this to pull files around from different locations in the repository. And again, you could also do something like git checkout and then the specific hash for the commit and mars.txt to pull the file from that specific commit by its name. So there's a warning here in the notes. This don't lose your head warning. And what it's telling you is important because this git checkout and then the name of the commit and then a file is very similar, does a very specific thing, which is to pull this file from the repository. But we can also run git checkout and then the name of the commit without the name of a file afterwards. So what happens when we do that? Say I want to run git checkout just the name of this commit. Okay, so we get a long message where Git tells us what it's just done, and it's effectively a warning, which is the same as what this warning about don't lose your head is all about. So it tells us that we're in detached head state. So that means that we've moved the state of a repository to the entire working directory to some point in its history. And this is a difficult thing for Git to deal with, and it's telling us that precisely that it's going to be a difficult thing for it to deal with. So you can look around at what's here, but it's telling you look. It's effectively telling you look, don't touch. Anything which you change here will cause real difficulty down the line. So don't change things here. You can look at what the state of things are here, so that you can potentially pull them into a different commit at the end of the branch, but don't change things here. Okay, so let's just get back to the end of main. So if I do git checkout main and then git log, you can see that we are once again at the added spaceships directory point so we've moved head back to the end of the branch. So we're no longer in detached head state. Okay, so let's think about some different things which you might want to do from these questions. So Say Jennifer has made some changes to a Python script that she's been working on for weeks, and the modifications she's made this morning broke the script and it no longer runs. I suspect this is a scenario most or many of us anyway have encountered before, that you've got some perfectly good code, you go and try to fix some small bug and you ruin everything. I've certainly done this many times in my life. So she spent about an hour trying to fix it and she's got nowhere. Fortunately, she's got the previous version of her code stored in a git commit. So what command will she need to run to recover the last committed version of the Python script? So the Python script is called data_cruncher.py. So she can run git checkout head or git checkout head datacruncher_py, git checkout head -1 of datacruncher.py, or git checkout, given a unique ID of the last commit, datacruncher.py, or both 2 and 4. The answer to this is clearly not git checkout head. Git checkout head is going to change all of the files in her current working directory to be what was in the last commit. So if she has other things stored and which she's edited other than just datacruncher.py, those could get overwritten as well. So that's a dangerous thing to do and something to avoid. Git checkout head datacruncher will work. That's exactly what we've seen so far in this lesson. Git checkout head -1 of datacruncher.py might fix her problems, but it's going to not get the most recent commit, but the commit before that for datacruncher.py. And then finally, git checkout and the unique ID of the last commit, datacruncher.py, will also work. In fact, that is effectively what this git checkout head datacruncher is doing, but it's got an alias, this head alias for that unique ID. So both 2 and 4 will work. So, and that will be fine. And she will get just the updates to datacruncher.py overwritten to be replaced with the previous version of just that script. Okay, so say she's working with other people on the Python script, and she realizes that the last commit to the repository contained an error, and she wants to undo it. So she wants to undo things so that everybody who is working on this repository gets the correct change. So the command git revert and then the name of the erroneous commit will create a new commit which reverts that erroneous commit. So git revert is different from git checkout because git checkout returns the files which have not yet been committed with the local repository to a previous state, whereas git revert actually changes everything in the repository, so in the history of the repository. So it is basically an undo for that. It's a note in the repository to say that you should that the entire previous commit has been undone. So they've given a missing command, which is just to look at the Git history of the project and find the commit ID, copy the commit ID, run git revert, type in a new commit message, save and close. So the missing thing here is just git log to look at the history of the project, which will show the different commit IDs. Likewise, git show head would show changes made at the last commit and list the commit ID, but it's always worth double checking that that is indeed the correct commit and that nobody's made and committed changes to the repository since then. So we've not talked about multiple people working on the same repositories yet, but that is something which we should get to fairly soon. Okay, there's another exercise here which I'll leave to you to come back over yourself. Then understanding git diff. So consider the command git diff head -9 of mars.txt. What do you predict this command will do if you execute it? What happens when you execute it and why? So this is going to go through and find 9 commits earlier in the repository and pull out the version of mars.txt for that earlier state of the repository at commit. Likewise, git diff with the specific ID will do it to pull it out for that specific ID. Right, there's a little bit of discussion here about how you can use a command called git log patch to specifically produce a thing called a patch, which explains the differences between two versions of files. Patches used to be something which were more frequently used when you were working with multiple collaborators to change things in repositories. They're much less frequently used nowadays because we have things like GitHub and GitLab, which consolidate different people's repositories together. So I'm going to breeze over that so that we have time for a quick break. So yeah, the takeaways from this section of the course are using git diff to show how different the state of different files and different and the entire repository differs between two specific commits, or so differs between commits and the current state of the repository, and how we can use the git checkout command to recover older versions of files and to have a look at the state of the repository at some point in history. Okay, the next section is going to be fairly quick. I will take a very brief, well, I'll take a 5-minute break and we can start again at 11, where we will pick up at this and then get going again. But I think it's probably a good idea for everybody to have a couple of minutes away from the screen. So I will be back at 11. Okay, hopefully everybody's had a chance to stretch their legs and make themselves more comfortable, whatever. Uh, Maybe even get some coffee. So I'll just quickly run through this next section, which is covers just kind of a useful thing, but which is not really especially deep information about how Git works. So frequently when you are working on a project or working on code or on say a LaTeX document, something like that, you'll find that you end up with lots of kind of temporary files and bits and pieces sitting around in the working directory, which you don't want to keep forever, which are not something which you want to keep for posterity. So LaTeX is a particularly good example of this as something that when you run PDF LaTeX, for example, it'll produce a vast number of files in addition to the PDF file. And indeed, you probably don't want to keep even the PDF file itself in the repository and just want to keep the things which are used to produce that PDF file. So how do we go about telling Git that there are certain things which I always want you to ignore and I want you to stop nagging me that these things exist in the repository, which I've not checked in, and stop yourself accidentally checking some of these things and then adding them to your Git history and making things messy and more complicated. So just to show you, let's just make a quick example of that. So say we've got some directory called results within our repository, and that's got some things like a.dat. Sorry, and we've got some, let's say we've got some data file which we're going to analyze called a.dat, and then the results of that analysis are results a.dat. So if we run git status, so we see that a.dat hasn't been committed to the repository, but we also get told that 2 seconds, let me get the terminal back. We also get told that there is this directory results which has got nothing, which has got stuff which needs to be committed as well. So we probably don't want to keep all of these results files under version control. So all of these results might change frequently, and that means that we'll have to keep a record of all of the changes each time we run, each time we produce a new commit, for example. So to get around this, we can make a file in the root of the repository, so in the main directory, and just call it .gitignore. So what we can add to this .gitignore file is patterns of types of files which we don't want to ever include in commits, and that we don't want Git to keep reminding us about. So say we don't want to keep those data files, we don't want those to be added, we can run add star.dat, so everything which ends .dat, and we can also add the entire directory results. So if we save our gitignore file now, and we run git status, you can see that the only untracked file now that it knows about is the .gitignore file, and it's ignoring the other things. So let's add our .gitignore file. And run git commit add list of files and patterns to ignore. Okay, and now if we run git status, you can see everything's happy, nothing to commit, even though there are these extra ignored files sitting in the repository. Now, if I try to add a.dat, which is a file which I've specifically said I don't want to be added to the repository, let's try adding git add a.dat. It tells us that in that's in a pattern which is ignored by the .gitignore, and that it's not been added to the stage. And it tells us that we really, really want to add it. We can force it with git add -f to add them to the stage. So there are some more notes again in the web page here about different more complex cases where you either might want to hide specific files rather than a pattern of files, or where you want to ignore nested files. And I'll leave that to you to digest for yourselves. But these are all variations on a theme. So this .gitignore file is the thing which you edit and add to the repository in order to always exclude certain things. You will find there are some good examples of these actually online where people have made them for specific kinds of projects. So they exist for Python projects, for example, where very typical files which are produced by Python and by various tools which sit around Python are ignored. Likewise for LaTeX. Say LaTeX is a particularly bad example of a thing which produces large quantities of unwanted auxiliary files in the working directory. And another thing which, if any of you, for example, use Emacs as an editor, you'll frequently find that Emacs makes backups of files every so often which look something like they would look something like a.dat and then a tilde afterwards. So it's often useful to add to your gitignore file. I frequently add asterisk tilde, so like this, so that those always get ignored, because otherwise you can end up with a whole pile of backup files sitting in the repository, which are kind of surplus to requirement, since your repository itself is acting as a backup, since it has the knowledge of the history throughout it. So these are just some kind of helpful tips and different things which it's nice to be aware of with Git. And as I say, it does not. This is not like a fundamental part of what Git is and what Git does. It's just a useful thing to know about, and it's a nice place to get started again after a quick break. Okay, now we are going to move on to the other major use of Git, which is how we work with other people, and indeed how we would work with our code split across multiple different machines. So how we go about sharing changes with others on the web, and yeah, how, say I've got a laptop and a desktop in my office, and for the last 2 years my desktop at home, where I'm working on code, and I'm working as I am, for example, at the moment, I'm working part-time in the office, part-time at home, and I want to make sure that I can work on my code in either place without too much faff. So one way that you might solve a problem like this is that you keep everything in something like Dropbox, but you can immediately see how that starts to become problematic if you want to keep all of this control of history as well. And fortunately, Git is a tool which is very specifically designed for dealing with this kind of problem with any kind of text file, particularly, but with so either code or with things like LaTeX. So again, the sorts of things which many of you are going to encounter fairly frequently. So this is the point where the notes argue, probably correctly, that version control really comes into its own when you start working with other people and working with code in other locations. And we've got most of the machinery which we need to do this already, and we just need to go about actually copying the code and the repository and the changes from one location to another. So from one person to another, one machine to another. So Git allows us to keep multiple copies of a repository synchronized amongst each other, and do this in a completely distributed way. In practice, whilst you can do this, often this isn't actually how people use Git. So you will find that it's quite normal to, in fact, have one central version of the repository anyway, even though it's sort of what they wanted to avoid with the design of Git. And frequently, you will encounter this central source of the repository being something like GitHub or GitLab, or even a service like Bitbucket. So there are several of these exist. GitHub is by far the largest um, uh, publicly available Git server. GitLab, some of you might have encountered because you get private installations of GitLab. So any of you, for example, who are LIGO people will have probably encountered LIGO's own GitLab installation, but it's something which is broadly comparable to GitHub and has a broadly comparable feature set. And then Bitbucket is another one of these, which we used to talk about in this course more frequently because Bitbucket used to also work under a version control system called Mercurial, but it doesn't anymore. So some of you may have heard mention of this before now. Any of these hosting services are fine. GitHub is probably the best one to use if you are working on something where you hope to get lots of different collaborators, because GitHub is just the largest and is where most open source developers have accounts. I think there is a discussion later on in the notes about which one is about the pros and cons of each of them. I don't think we're going to get onto that, but do feel free to go check that out later on. Okay, so this is going to talk about how you go about setting up a GitHub repository. Don't worry if you don't have a GitHub account, you can come back and go over this yourself later on. I will demonstrate it this morning, and you can come back and work with it later. So to do this, I'm going to go to github.com. So when you have an account with GitHub, you get something like this. When you log in, you get given a list of all of the repositories which you have and which you contribute to, and there will be a button either here for a new repository, or just a moment, I need to move myself. Or there is a button up here to add a new repository. So we can go to add new repository. And then we just need to give the repository a name. So I'm going to call this SWC 2022, but you can call it whatever you like. So I think the tutorial is going to have us call it planets. But as you see, I actively use my GitHub account for other things, so I'm going to call this something which I actually understand what it is. You can give it a description. So I'm going to say it's a teaching repository for the SWC Git course 2022, and then I can choose to whether to make it public or private. So for a normal account on GitHub, you're limited to a certain number, I think, of private repositories. You can apply to get a GitHub for Education account, which is what I have, which allows you to have more of these. But in general, if you want other people to work with your code and to see your code, you'll want it to be a public repository so that they have access to it. But there are situations in which you'll want potentially to have a private repository as well. Yeah, they're saying that we should set it up as a public repository, so let's set it up as a public repository. You have the option to do things like add a README file, add a gitignore file. So I'll show you what this looks like. When you click it, it gives you a list of different template gitignore files. So this is what I mean, that you get options for things like a Python gitignore file. If you are setting up a completely new repository and you've not started anything yet, this is a good thing to do. Don't do this if you've got a repository which you are preparing to push to GitHub like we do, because it will make your life more complicated if you do that. So, I'll not add gitignore and I'll not choose a license. We'll talk about this licensing stuff hopefully next week in the final session for software carpentry, but for now we're just going to leave all of these checkboxes blank and just create a completely empty repository. Okay, so that's the repository created on GitHub. Um, then, and this is the address where it lives. So uh, it we get told some instructions about different things which we can do. Um, so what has basically happened is that GitHub has done pretty much the process that we did on our own local machine. It's made a directory somewhere, CD'd into that directory, and it's run. Oh, okay, thanks, Michael. Yeah, so I think GitHub do have unlimited private repositories, but there is some other limitation on what you can do with the private repositories, and I've forgotten what it is. Um, there is some limitation. Yeah, it is something. Yeah. Anyway, the um, so we can run and basically then GitHub has run git init to make a new repository. It has actually done something subtly different from what the notes tell you here, which we don't need to worry about. But it's made a very specific kind of Git repository, which is one which can be um, copied from multiple different places. We don't need to worry about what that is. I'm just being pedantic that this is not strictly correct. And if you wanted to set up your own simplified version of what GitHub is doing, then you could not just do this. You would need to do something slightly different. Okay, so we've got our remote repository now on GitHub, and we need to connect our repository, the repository which I've got here, which we've been working on. We want to connect that to the remote on GitHub. So how do we go about doing that? Well, you'll see that there were some instructions here basically telling you what to do. And it's kind of helpful that GitHub tells you this because I suspect I would um, myself easily forget the exact syntax that we need, but it's this git remote add origin thing. So let's go back to our terminal. So if I run this git remote, so git remote is the collection of all of the commands in git which interact with different settings for remote repositories. So for ones which are separated somehow from the repository which you're currently working on, but which are copies or designed to be copies of it. So we can say git remote add, so to add a new remote. We want to call it origin. So origin is a is frequently what people call the repository, which is sort of this centralized, notionally centralized version of the repository, and then an address for it. Uh, so uh, in reality, because of the way that I've got my GitHub set up, so and if you've already used GitHub and you have it set up to use two-factor authentication, this HTTPS version of the address will not work. So I'm going to change this to the SSH address. So if we have a quick look up here, we have the option between HTTPS and SSH. So if I choose the SSH one, and then we'll use this SSH address. Okay, and if I run this, it just happily runs, tells me that I've added, well, it tells me nothing, but I can run git remote show. It'll show me that this origin exists. I get git remote show origin. It'll think for a moment, and it'll tell me that that origin is a remote. It'll tell me the fetch URL and the push URL, which are both two locations on GitHub, and it'll tell me that it at the moment doesn't know anything else about the status of that repository because we've not so far done anything with it. We can also run git remote -v, which will just give us a list of all of the remotes like this. Okay, so there's some discussion in the notes about why I needed to use the SSH. setup rather than this HTTPS setup. I'm not going to get into the nitty gritty of all of this. There are some notes which will explain this. You do need to do some setup to get this to work. It is just for added security. And again, as I say, I use my GitHub account for actual collaboration, so I do have this extra security set up on it. If you are new to your GitHub account, you may not have this, and you may be able to use the simpler setup. So I will let you go through this yourselves later on when you come to it. It's a useful thing to be able to do, so it allows you to push to your repositories without having to put in a password every single time. It uses some reasonably clever cryptography techniques to allow this to actually happen. But again, it is kind of slightly out of scope, I feel, for what we actually want to do. You produce this thing called a public-private key. You keep your private key on your machine, but you can give a copy of the public key to GitHub so that it's able to verify that you are who you say you are. And again, the notes explain how to do this, and you just need to go through step by step and do it, and it should just work. Okay, back on track. So we have our local version of the repository on our own machine, and we got this version of the repository on GitHub. You can see from all of this, the repository is currently completely empty. So we want to send what we've already got on our machine up to GitHub. Well, how do we do that? Well, let's run a new command, git push. So git push basically tells Git to take all of the commits which it's got and to send them somewhere else, to push them somewhere else. I want to say, I want to tell it, I want to push to origin. So that's what I call the GitHub repository. What do I want to push? Well, I want to push everything which is on main. So everything on this branch called main. Git push origin main. And run that. Okay, it tells us some stuff about what it's actually doing to to send all of these commits off. And then it tells us at the bottom, it's been sent to github.com and then my SWC 2022 repository. And it said it's created a new branch and it's pushed a new branch called main, and it has pushed my branch called main to the remote branch called main. So let's have a look at what this is now going to look like. So if I refresh, we can now see that GitHub has a copy of our repository, including spaceships file, the .gitignore file, and crucially this mars.txt file. So that's good. That is what we hoped for. So again, in the notes, there's some discussion about using things like password managers and proxies. I'm definitely not going to get into either of those. Those are both kind of edge cases, but the notes do cover how you can deal with things like AskPass, and there are other means of dealing with your passwords for things like SSH connections. And if we have time at the end, I can happily chat a bit about that. But again, the notes do cover it for at least some cases. Okay, so notes again. So what's happened here is we've taken everything from our repository, and things which have gone through the staging area into the repository, and we've taken this and we've done git push origin so that all of the stuff from our local machine has been pushed up to GitHub and is sitting in a silo like this, so in the repository with all of the different commits. One other thing which we can do, which is kind of useful, is when we run git push, we can do, so this git push origin main command is quite lengthy, and it becomes a nuisance to type this out every single time that we're doing a git push. So say we're expecting to, when we when we do a git push, we're always expecting to push main to origin. We can just run git push -u origin main. Okay, so nothing happened in terms of nothing got pushed to GitHub, but I have now set up the branch main to track the remote branch main on origin. So that just means from now on I can run git push on its own, and it will do the same thing as what previously I had to run git push origin main. If you happen to be working for some reason with a remote which is not origin, so which is not the GitHub one, or you're working with a branch which is not main, you'll need to write out the full command. At least unless you set things up slightly differently. And again, but ordinarily, for most cases, you're principally working on one branch with one remote. So this is a useful thing to set up. So just very quickly, we can have a look at some useful things which exist on GitHub. So GitHub obviously presents all of the same information which you get through the git command, but it presents it in a slightly different way. It's sometimes a little bit more user-friendly. So for example, rather than running git log to look through all of our commits, you can just click the 5 commits here, and you can look through the list of all of the commits which exist in the history for the Git repository. And you can see here that having this is slightly easier to look at. You can see all of our commit messages, the short name of the commit. We can click on any of these commits to get more details and to get the diff. So GitHub has kind of a nice user interface to look through all of these different things. You can also set things up so that, so for example, when I told you earlier on that I had to put a password in to produce a commit, it was to make this thing work. So these verified commits are just that Git has signed all of the commits with a digital signature produced through a tool called GNU PG. Don't worry about what this is right now. It's just a thing which Git can do so that you can verify that the person that the person with the email address who claims to have made the commit actually is that person. So it's occasionally a useful thing to have, but it's not something, again, which we need to worry about particularly. It's relatively unlikely that any of us will really need to worry about this too much, since high security things are rarely something which you'll come across being fussed about in sciences, right or for wrong. Okay, so there are some more things in the notes here which talk a bit about the things like setting up the time zones correctly for GitHub and so on. So one question, let's have a look at it. Yeah, so push versus commit. So in this chapter, we introduced the git push command. So how is git push different from git commit? So remember that git commit is the thing which is used to produce individual snapshots, and git push is the thing which takes the list of all of those snapshots, so the history of all of those snapshots, and it sends it to some other remote repository. So when we push changes, we're interacting with this remote repository to update it with the changes which we've made locally. And those changes are made locally using git commit. And those initially, anyway, only affect your own local copy of the repository until you push them to somewhere else. So this raises a useful point, I guess, which is you do always need to remember, for example, at the end of the working day, to do something like run git push to send all of your changes to the remote repository. The number of times that I have worked on something in the office and decided I'm going to go home, work on it from my laptop at home, forgotten to run git push, realized that all of the changes are left on the office machine, and I then either have to connect to the office machine to run the git push remotely on that machine, or possibly more healthily from a work-life balance perspective, I've had to not work in the evening. But yeah, remember, git push needs to be something which you do potentially after each commit, but at least reasonably frequently. Yes, they've got some discussion about licenses and README files. Feel free to have a look at this section, but we will talk about this more next week in the software engineering principles lesson as well. Okay, so in this section, we've just talked a bit about how our local repository on our machine can be connected to a remote repository. It can potentially be connected to multiple remote repositories, although we've not seen that so far. And we've seen how we can use the git push command to send changes from our local version of the repository to GitHub. The one thing which we've not seen, and which I have somehow skipped over, is using git pull. So say we make some change to the remote version of the repository. So ordinarily, I wouldn't recommend making big changes to the repository on GitHub, but just this once so that we can see what's going on here. I'm going to need to move myself again. So when we're on GitHub, we can actually edit files in the repository directly through GitHub. So if I click here and edit this file, so say I want to add some notes. So we'll need to take our own water, something like that. So I add this new line, commit changes, the default commit message, update mars.txt is exactly the kind of thing which we should be avoiding. So let's give a slightly more informative commit message, added note about water. Yeah, this is the email address which I want with the commit, so and I want to commit directly to the main branch. Okay, so now the version of this file which is on GitHub is different from the one which I've got on my own machine. So if I go back to my copy of the repository, we can see that cat mars.txt, we're still missing that last line. How do we get the changes which have been made to the remote repository? So in this case, made through GitHub, but it could equally be that somebody else had got a copy of the repository, had git pushed their changes to that GitHub repository so that it was up, so that there was a newer version on GitHub than what I had. How do I get those changes? Well, there's a git push, so perhaps unsurprisingly, there is a git pull. So if I do git pull origin main, Git goes through, it checks for the changes which have been made in the remote version of the repository. It finds that there is indeed a new commit, so it will pull that commit down, update my repository, and move the head of my repository to the new latest commit. So if we now cat mars.txt again, we'll see that the copy that I have got the updated version of that file pulled down from the Git repository. So that's good. I can also just run, because I'd previously done that git push -u thing, I can also just do git pull because it knows that it's tracking origin main. So git pull in this situation is also a working shorthand for git pull origin main. Okay, so we've seen git push and now we've seen git pull to get copies of changes from the remote repository into the local repository. Okay, so collaborating. Once we've got this remote version of the repository on GitHub, somebody else is going to want to come along and get their own copy of it. So how do they do that? And then how do we deal with conflicts and changes which two different people have made, perhaps to the same piece of code? So we're going to talk a bit about how that works and a bit about different ways of trying to manage that. If you're working through this lesson on your own, and I appreciate we are all together on this call, but when we were sitting in person in the lab before things changed, we would try and pair people up. That's not really going to work on Zoom. So to try and get around this, you can attempt to run Git in, for example, two different terminals. That's what I'm going to do when I'm talking through things here. So hopefully I have this set up. Oh, I almost have this set up. Okay, I will set this up at some point, but let's, for now, get started on this and I will briefly break to fix the problem. So the first thing which we need, the first thing which the notes talk about, let me get that back. The first thing the notes talk about is how you let other people have access to your repository. So by default on GitHub, things are set up so that you are the only person who's allowed to push to a repository, but if you've made the repository public, other people are allowed to pull from the repository. Now, there are two different ways of managing people sending you updates, so pushing things to you. One is that they can have direct access to the repository, so that they're able to push changes to the repository themselves. And there's a more complicated workflow, which is in fact what is in practice more frequent, which is where people make their own copy of the repository, and then you go through a process to where you, as the principal owner of the repository, pull their changes into your repository, and they send you a request to do that. But we'll start out by looking at the direct model because it's simpler, or at least it's a bit simpler to understand what's going on. But this merge request model or pull request model, depending whether you're using GitHub, which calls them merge requests, or GitLab, which calls them pull requests, that is in fact more common particularly in big software projects. So if you are working on like a big collaboration software project, for example, that is how you will do things. So on GitHub, to give somebody direct access to your repository, you need to go into the settings on the repository. Up here at settings, access and collaborators. To put in your password so that you can do this, and it will. So you can see it says that this repository is public and it's visible to everyone, but 0 collaborators have access to this repository. And you can invite new people to be collaborators by going down to add people, and then you can add their email address or their username. So I could, for example, add Michael, our fellow demonstrator, as a collaborator here, or I could add anybody with a GitHub account or anybody with an email address I could add as a collaborator to the repository. And then it'll send them an email to invite them to either sign in with their GitHub account or to create a GitHub account so that they can collaborate. I think I don't need to do this for what's in the rest of the notes, but if I do, I will come back and I will rope Michael into being a collaborator on the repository. But yeah, this is what you need to do so that they are able to git push to your copy of the repository. For small projects, thanks, Michael. For small projects, this is fine. For bigger projects, it just becomes unmanageable, which is why there's this more complicated model for working with bigger projects. Okay, I'm going to do this on my own machine, and I'm just going to very quickly take a 2 or 3 minute break to set this up. It was working before I started, and now it is broken again. So bear with me just a moment, and you're going to see. Let me try and set it up so you can see both of my terminals. Okay, so hopefully you can now see two terminals. I apologize if the text is a bit small. Let me know if it's illegible, and if it is illegible, I can try and make it a little bit bigger. So on the left here, I've got the terminal which we've been working on throughout. On the right, let's pretend this is a different machine where some collaborator is going to start to make changes to the repository. So I'm going to just move into a directory where I can make a copy of this repository. So to get a copy of the repository from GitHub, I'm going to use a new command, which we've not seen so far, called git clone. So on GitHub, you'll see there's this green button called code. And one of the options which it gives you to get access to this code is under clone. And we can just copy this address. This is the address which I need to run the clone. So cloning is just copying a version of a remote repository onto your own machine. So if we go back to here, if we run git clone and then paste that address, you'll see it says that it's cloning into SWC 2022. And now I can cd into SC 2022 and run ls, and you'll see that what I have here is exactly the same. In fact, I need to run ls-a to prove this. So if I run ls-a, you can see that I have the .git directory. So this is a Git repository. I've got the .gitignore, the mars.txt, and the spaceships directory. So all of the things which were in our GitHub copy of the repository. We now have these two different copies of the repository. They're both connected to the remote on GitHub, but they're not connected to each other. So this is basically the setup which we would have if these were two different machines, or two different people working on them. Okay, so I can now start making changes to the copy of the repository on machine 2, and we can see how this affects what's going on with machine 1. So say I want to add some notes about the potential of Pluto, for example. So nano pluto.txt, and I want to say it is definitely a planet. The IAU was wrong. Okay, so we've got this file pluto.txt with this incendiary note about the International Astronomical Union. So I want to add this to a commit in the repository. So I'll do git add pluto.txt git commit -m added Pluto added notes about Pluto. Okay, so I've added this new file to a commit. I've made the commit. So now I want to push this back to GitHub. So I run git push. I'm going to set up this remote. So origin main. Okay, so it said that it's pushed main up to the latest commit on main up to GitHub. So let's just have a look if that has changed things. So go back to GitHub and just refresh this. Yeah, you'll see now that pluto.txt exists in the remote on GitHub, and it exists on our machine 2 version of the repository. Okay, so that has been pushed up to the remote, but our machine 1 now is behind. No longer has all of the updates which machine 2 has. So that machine 1 can get access to those, we obviously run git pull or git pull origin main to be complete, but git pull will work as well. We run git pull origin main, and then if we just do ls, we can see that we now have this pluto.txt file. And again, remember we've got this .gitignore file, so that this .dat file and this results directory are ignored from the repository, which is why this looks a little bit different from what is on the right. Okay, so a very basic workflow for working with a collaborator then is that you try and keep everything in order, so that you say, you know, on Monday I'll do some work on this repository, I'll make my commits and I'll push them back up, and then you need to remember to pull your commits before you start working on Tuesday, do your work on the repository, etc. Commit, push. That's fine, and that's a kind of intuitive, understandable way of working with this, but it's probably not practical in the long term. So aside from anything else, making sure that only one person is working on the repository at once is going to be difficult to do. But in reality, you know, what happens if person A forgets to push one day, person B starts working on it later, and then you get the two states of the repository being different, and somebody's got to come along and try and work out how to reconstitute things after all of these changes have been made. Well, this comes to possibly one of the most powerful and complicated things which Git tries to do, which is to merge different versions of repositories together. Very quickly before we get to that, let's just have a look at some of the notes at the very end of this section. So, say one person's pushed commits to the repository without giving any information to the other person. So say I've been working on the repository on Monday, I've pushed things to GitHub, but I didn't email the other person to tell them what I've done. So how does the other person check what's happened without that email? And but to be honest, this is kind of a useful thing to be able to do. You don't want to have to repeat yourself and send emails all of the time, for example, to say what you've done. So what do we do? Well, instead of running git pull, which will pull all of those changes in, if we just want to look at what those changes are, we could have run git fetch origin main. So that goes and looks at the remote changes and pulls knowledge of those changes into the repository but it doesn't attempt to merge them into the repository. So it doesn't change the state of our repository to reflect the state of the remote. So once we've updated our repository so that it has knowledge of these changes, we can then run git diff, and then say git diff of main with origin slash main. So origin slash main is what Git calls the branch on origin, which also has the name main. Then you'll see the diff between your version of the repository on this main branch and the remote version on this main branch. You could also go on to GitHub and just have a look at the list of commits, which are present on GitHub. A useful, nice thing which GitHub has, but which doesn't work with the command line, so which you therefore need everybody to have a GitHub account and all to be using GitHub for, is that you can make comments, line-by-line comments on changes on GitHub. So say I go into my commit here, and I want to make a comment on it is definitely a planet, the IOU was wrong. I can just click this little plus button and leave a comment here. So this is useful if you're coming to do code review, or if you want to have some sort of conversation about the changes which you have made in the code. So let's say, I think this might be, controversial. I can just add this comment. So you can see that GitHub now has this comment attached to this, so that it's just part of a code review or something later on. So that's quite a useful little feature. Yeah, so then there's this question, this is something really to think about, is some backup software can keep history of specific versions of your file. So something like Time Machine on a Mac or Duplicity on Linux can keep a history of different versions of your file. And they can allow you to recover very specific versions. So how is that function different from what we're doing with Git? What is the difference between that and version control itself? So the principal thing which I can think here is that version control allows you to define the points at which you make these commits and these snapshots. So the way that I have things set up on my machine, for example, a backup gets made once a day, and then a bigger backup gets made once a week. So if I have made lots of changes within the day, I can only go back, say 24 hours to what was previously available in the repository. It's also much more difficult with that kind of software to look at differences between different versions of the code. So those kinds of backup solutions are really designed for large-scale backups of your entire machine rather than of very specific projects. And they don't, of course, come with these features to allow more advanced collaboration either. Okay, so this section we've talked a bit about using git clone to get access to remote repositories, and we've also talked about using pull and push to move things around, and we've very briefly touched on this git fetch command as well. So we have 45 minutes left. Let me just check how we are doing time. Okay, we're actually doing quite well for time. So yeah, let's very briefly take a couple of minutes. So let's take 2 or 3 minutes. I just want to go refill my coffee, and we can get back and talking about conflicts. And this is what happens when two different people have worked on the repository independently, and the changes which they have made cannot be merged together easily. So if they've both changed the same piece of code, I will be back in about 2 or 3 minutes. Okay, so we are into the home stretch now. As I say, the next section which we're going to talk about is this conflict section. We'll talk a bit about this open science section as well. There are going to be some notes about licensing, which I will not talk about today because it's a duplication of what we should talk about next week, although do feel free to go have a look at this. And I will try and cover the citation section and maybe the hosting section. The hosting section is new since we did this before, so we can have a quick look at it, but I suspect I won't have strong opinions about it. We won't be using this Git from RStudio thing. That's a very specific, that's a talking about a very specific tool, which I don't use R and therefore don't use RStudio, so I'm not the right person to talk through that with you. But if you are somebody who uses R extensively, I'm sure that will be helpful to you. All right, so conflicts. What do I do when I get into conflict with somebody else? So this is the SUPA course on de-escalating tensions, or in reality, it is the SUPA course on what we do when two people try to change the same piece of code or the same document or the same file. So as soon as people work in parallel, they're going to start excuse me, making changes which affect each other and which step on each other's toes to some extent. So you're both working on a piece of software, then you might end up, two people might end up making changes to the same function, which overlap in some way. So version control and very specifically Git allow us to try and manage these conflicts, giving tools which allow us to both resolve those conflicts, sometimes automatically, and sometimes to help us to do that manually. Okay, so let's go back to the situation where we have two different people and two different terminals open at the same time. Okay, so at the moment we both have the same version of mars.txt on both terminals. These both look identical, both the same version, and if we run git log in both cases, we will see that head is sitting at the same commit in both of them as well. Okay, now say on machine 2 I want to add some extra information. So I run nano mars.txt and I say this line was added just to Wolfman's copy. Okay, I add that, I save that. I'm gonna add it to the stage and then make a commit. So add a line in our home copy. That's what they suggested we use, but okay, so we've added this this new line and committed it. Let's now push that to GitHub. Okay, so that's been pushed to GitHub. Now, let's say the other person also decides to edit that file. So we just say we added our own line to this copy. So again, we add this to the repository and then commit it. and we will push this to GitHub. Something's gone wrong. So we had an error, failed to push some refs to GitHub, so to the GitHub address. And it tells us why it thinks this is. So it's because updates were rejected because the remote contains work that you do not have locally. So something's going wrong here. And it says this is usually caused by another repository pushing to the same ref. So there's some other copy of the repository who's pushed to the GitHub repository. You may first want to integrate the remote changes before pushing again. When it says you may want to, and that is basically what your option is here, is to try and resolve this, the two versions of the repository. So we have these two different copies of the repository. Git doesn't know what to do. So as it suggests, we can run git pull to get those remote changes. Now you might be concerned, will git pull not overwrite the changes that we've just made? The answer is no, because we have made a commit. So that commit exists in our local repository. But things are temporarily going to get slightly messy. So let's see what happens. So let's do git pull origin main. Okay, so it's gone and it's pulled these changes. It's attempted to, so you see it's got this line saying that it's auto-merging mars.txt. So this is Git attempts to reconcile the changes between the two versions of the file itself. And then it says there's a conflict, and it's a conflict over the content of the files. And the automatic merge failed, and that we need to go and do something manually. So it tells us fix the conflict and then commit the result. Okay, so what has happened? Well, let's have a look at what Git has done for us. We run cat mars.txt, just so that we can see what is now sitting in that mars.txt file. You can see that there's something which is kind of looks initially like a bit of a mess. So we've got both of the things. So we added our own line to this copy, which is from our local machine, so machine 1. But we've also got this line was added to Wolfman's copy, which came to us from machine 2 on the right. So this thing which is put in here is just this diff, which shows us the difference between the two things, and we need to decide how to resolve this. So the simplest thing for us to do is just to open this in an editor and manually reconcile these changes. And that's a perfectly straightforward thing to do when we've only got this one change to deal with. So let's open nano mars.txt. So we have the option here, we can just delete everything except for we added our own line to this copy. We could keep both of them, in which case we would just need to delete all of this stuff which Git has added, or we can delete everything and write something else to deal with the merge. So let's say we removed the conflict on this line. Let's do that, and we'll, instead of keeping these things, we'll just delete all of it. But we have the option to keep any part of it that we want at this stage, or to manually merge those. And then we just want to, the important thing is that we get rid of these lines which have all of the chevrons in and the separator equal signs. So those are just there so that we to separate things out and make clear what Git has done for us. Okay, so we've made this change. So let's save that. If we run git status, we can see we've still got this unmerged thing because mars.txt has this merge conflict. To resolve this now, I need to do git add mars.txt since I've made the appropriate changes. again, if I now run git status, you'll see that things look a bit more normal, and it tells me that this is just a change waiting to be committed. So I do git commit -m resolved the merge conflict between Vlad and Wolfman. Okay, so now we should be able to remember the entire goal of this was that we wanted to be able to take our changes from this machine and push them back up to GitHub. So hopefully now the history of everything from the machine on the right over here. Sorry, I'm mirrored, so everything on the right and everything on the left should now be have been pulled together and synchronized. So when I do git push, everything should be able to be pushed up to GitHub, and everything looks sensible and in a resolved fashion. So let's just have a look at what the repository now looks like on GitHub. So we can now see mars.txt has been pushed, and we've got up to this resolves the merge conflict between Vlad and Wolfman. We can have a quick look at what's gone on with all of these commits, and you can see these are the two commits which had the conflict, and everything has been merged up properly here. So likewise now on machine 2, so on the right, we can do git pull. Excuse me, I'm just going to close the window. There's a lawnmower outside. So on the right, we can do git pull, and you can see that the changes which have been pushed to GitHub have been successfully pulled down into machine 2, and everything should now look the same between the two of these. So if we do cat of mars.txt on the right and cat of mars.txt on the left, we have the same file again. This is a very basic process of how you go about resolving one of these merge conflicts. And it's nice and straightforward if it's only simple and small numbers of conflicts in the file. So it's generally quite good to try and develop a workflow where you aren't going to come across very large numbers of conflicts between different versions of the repository, because it becomes more and more complicated to do the more conflicts you have, in effect. And there are tools which help dealing with larger merge conflicts. And if any of you are, for example, Emacs users, there is a mode within Emacs which helps you to work with these called emerge, which just allows you to basically speeds up the process of basically choosing between yours and the remote version of the change. But it's something which you want to avoid as much as possible. So some good practices for reducing the frequency with which you need to do this and reducing the complications, to make sure that you pull from upstream from the origin repository on GitHub, for example, frequently, and especially before you start new work, so that you always have the freshest version of the code possible, so that you're not doing something. And I will admit that I'm prone to doing this kind of thing, working on code which is 3 months out of date, realizing you've made lots of changes, and then when you try to push to the remote repository, realizing you've then got to resolve merge conflicts between months worth of work. That is something which you really want to avoid. It's difficult to deal with. There are other solutions to dealing with that kind of problem, but nevertheless, it's not a pleasant situation to be in, and one which you really do want to avoid. Yeah, I think we have all been there. So some other suggestions which they have in the notes are to use topic branches to segregate your work. So if you are working on, for example, adding a specific new feature to your code, you can use a branch within a repository to do all of that work on, so that you aren't constantly having to integrate new changes which are on, for example, the main branch. So um, that this isn't a completely flawless approach either, because you will eventually come across code coming off. So there will eventually be the point where you have to merge your branch into the main branch, and where you've got to do lots of potential merge conflict resolution, but you only have to do it once right at the end rather than multiple times. I'll talk in a moment about what a bit more about branches, because we've kind of managed to largely skip over what branches actually are. And we have a little bit of spare time, so I'll talk for 5 minutes about branches in just a moment. Another suggestion is that you should try and aim to make smaller, more atomic commits. So that's a good idea as well. So again, it's easy not to do this, and I'm as guilty as anybody else of spending an entire day making changes right across an entire code base, coming to do a commit, adding 16 files to the commit where I've changed hundreds of lines of code. And then when I come to push it, I realize that I have changed many, many things which conflict with something in the remote repository. I have to spend ages fixing up this merge. Whereas if I had done everything in little bite-sized chunks, it would have been easier to manage as I went along. So making small commits fairly frequently is good from that perspective. It's also much more helpful for the actual version control aspect of things. So we're being able to take steps backwards through the history of the repository itself. And yeah, the final suggestion which they've got in the notes is that you should. Final suggestion they've got in the notes here is, where logically appropriate, break large files into smaller ones. So that it's less likely that two people will work on the same file simultaneously. That's generally good advice, and it's good advice for reasons other than just version control as well in most situations. So, for example, if you have some, Python project, don't keep thousands of lines of Python code in one script. Have one script file which calls some functions which are imported from one or more file, module files around the place, for example. It's just it's easier to find the code, for example, as well, but it just reduces the chances that two people are going to end up stepping in each other's feet if things are kind of logically and sensibly organized. And yeah, the best way of trying to avoid major merge problems isn't technological; it's purely human and managerial, which is making sure that somebody is actually in charge of the development of the repository. So having somebody who is kind of the lead developer who helps to coordinate things, actually discussing with other people what you're doing. So not going off and spending 3 weeks working on the code in complete isolation and then hoping that your changes aren't going to conflict with what somebody else is doing. Talking to other people and coordinating with them helps a lot. And yeah, the final suggestion which they make here, I think, is sensible, but can introduce its own problems, which is that if you're frequently getting conflicts which are stylistic, so a good example of this in Python is some people using tabs rather than spaces, is that first of all, you have some defined convention between the people working on it. So you all say, well, you use spaces. Spaces are the correct thing to use, and don't use tabs. This isn't just my opinion. This is actually this is what Python officially recommends, that you use spaces rather than tabs. But you can also use specific tools which go through and tidy up the style of your code. So yeah, they've got some suggestions for HTML and Perl here, which these are things called code linters, which just go through and automatically tidy things up. Again, there are equivalents. The equivalent for Python is called pylint, and it just goes through and it automatically resolves these things. So suggesting that people run these things before they make the commit, for example, is a useful way of just reducing the number of conflicts that you might end up with. Um, so it is perfectly possible. you to create conflicts on your own within your repository. So if you're working with different branches as well, so trying to keep your own work organized is probably sensible. We're not going to try this exercise which they suggest here. We just don't have time, I'm afraid. But the process of fixing whatever conflict is made would have been made in this exercise is just what we talked about. Would do this git pull and then manually edit the file. So one question is, what does Git do when there's a conflict in something like an image or some other binary, so non-text file, which is stored within the repository? This is a good question. So the example which they give here is of using a text, a JPEG file, which is stored in the repository. Now, for various, well, this is going to show us the reason why storing non-text files in Git repositories is not always a good idea. But he's added in. He said it's a picture of the Martian sky, and then somebody else has added another text file, which another image file which has got the same name, so another mars.jpg file. And these are both added in, and then we get the same conflict. Git looks at it. It doesn't even attempt to auto merge. It says that it can't merge binary files. That's something which is not possible in the Git merge algorithm. So it says automatic merger failed, fix the conflicts and then commit the result. So what happens here? Well, so Git, instead of adding the two changes to both to the same text file as they did before, this time it pulled down the two versions of the commit, and it's told us that we have a version of mars.txt which is sitting on head and a version which is sitting on this commit here. And we, oops, where have I gone? We've got this second one sitting on this commit here. So basically we need to look at these two different versions of the file, decide which one we want, do a git checkout of either the head version or of the other version, add that and commit it again. So it's a bit more complicated than what you would do with a text file in order to resolve this. We could also potentially add both of them, but we would need to rename one of them. So we need to do a git move on the one which is sitting on head so that they both have unique names. Yeah, so this is a good example why Git does not deal with binary files well. But analyzing binary files is substantially harder than analyzing just a text file, and it's not something which Git is designed for. This same problem comes if you have two different versions of the binary file which are stored within the repository. Git isn't able to just look through and say, these two lines have been changed, so all I need to store in the history is the fact that these two lines changed, which is what it does for a text file. It instead has to keep an entire record of the binary file each time. So that's fine if you're working. That's maybe fine if you're working on a repository which doesn't have a lot of commits and which doesn't have a lot of these binary files. A good example of a situation where it really does not work well happened to us in LIGO, where we were storing binary files which contained, hundreds of megabytes sometimes of results, which were stored in the repository, where each time these big results files had to be copied in the history, and we were rapidly developing these, hundreds of gigabyte repositories, which is something which you really don't want. It's not optimal, and yeah, it just slows things down. So if you find yourself thinking about adding a binary file, often you want to think, is this the sensible thing which I want to do, or is this in fact something which has been produced by all of the files which are already in the repository, and which I can just write a make file for, commit the makefile to the repository, and run that makefile to produce those binary files anytime I need them. Okay, so the major takeaways from this chapter, and this is the last major chapter which I'm going to talk about, are that conflicts occur when two people change the same line in a file, and that we've got different strategies in the version control system for dealing with that. But basically, it will tell you where the conflict exists, show you what the two different sides of the conflict are, and then allow you to manually choose how you want to resolve that conflict. If the conflict, if there are two different versions of the file, but they are not edited on the same line, so if I added a line at the top of the file and the other person added one at the bottom of the file, Git will normally be able to deal with this situation by deciding automatically that you want to add both the top line and the bottom line of the file. So that is a simpler case which we've not actually looked at. Okay, before we get on to the open science thing, I'm just going to very briefly talk about what these branches are, which I keep talking about, because I don't think we're going to get onto them any other way, but they're a useful thing to know about. So kind of a whistle-stop tour of what these are. So say I've got my Git repository here, and I've decided that these Mars notes need to be completely reformatted. So I want to spruce them up so that they look a bit better, but I don't want. I'm doing this in such a way that this is a kind of a self-contained project, and I want to later on be able to merge this back in with the rest of the repository. But I don't want to have to worry about what people are doing to like the venus.txt file or the pluto.txt file or whatever along the way. So I want to have some sort of kind of semi-independent state of the repository to play around on. So this is what I want a branch for. So I can run git branch testing, for example. So that makes a branch called testing. If I run git branch, you can see that I've got main and testing. And I can run git checkout testing. So now, if I make some change to mars.txt while I'm on testing, so for example, I want to start adding headings. So climate notes. So say I wanted to make my file like that, and I want to keep working on, developing this file, but again in a way which doesn't affect other people's view of the repository. So I can add mars.txt, git commit mars.txt. Oh, I forgot to do git commit -n. So this is the thing which I was telling you. If you just write git commit, you get shown the editor. It just opens Nano for me here, and I can type started reformatting work on Mars notes. Okay, so that has been changed on the branch. So if I have a look at mars.txt, it looks like that now. If I do git checkout main, you can see that the version on main is still the old one, but the version on testing is this. I can push this to GitHub, so that there are now both versions on GitHub. Git push origin to push it to GitHub, and testing. And now if we have a quick look back at GitHub, we can see that by default, GitHub shows us main as the branch. The view which we get is main. But we can also change this to testing. Go have a look at Mars, and we can see that this is the version which we've now got. So the branch approach is good because it allows us to have this semi-independent thing which we can then merge in later. Now, We do not have time for me to talk through this right now, but one option is that I can make a pull request on GitHub, and I can say that I want to pull testing into main, for example. So we can do this through GitHub, or we can do this locally on our own machine. So if I do git checkout, go back to git checkout main, and then I can pull all of the changes which have been made into that testing branch by doing git pull origin testing. So now it has merged everything from testing into main. So if I do a quick cat of mars.txt, you'll see that those changes which were made onto into that testing branch have now been pulled back into our main branch. And that was, in this case, only one commit, but it could have been dozens of commits. And what we'll have pulled in at the end is the final product from that branch. And because we've now edited the main branch, we'll need to do a git add mars.txt git commit minus merge testing branch into main. And then we just do a git push, and then everything on the main branch on GitHub will look like it does for the testing branch. That is what branches are for, as kind of at kind of breakneck speed. But while this might seem like kind of a trivial example, and it kind of is for doing this, it can be really useful if you are working, say, on some big code project and you want to add some new feature which is going to take weeks, months worth of work, which is going to be relatively isolated from everything else in the repository because it's some new feature which exists in some new place. But you don't want to have to deal with looking at all of the updates which have been made to everything else every day, for example, when you start work on it. And it's just nice to have it in a slightly isolated place so that people can see what this change is. And as you work with, if you ever work with big collaboration repositories and branches and so on, you'll be aware that people use these branches quite frequently, and it's just useful to know what they are. Okay, very quickly, let's finish up with the discussion, the very last section of discussion here, which is this, which we're going to get onto, which is this open science stuff. So the whole point of version, well, a major thing which version control allows us to do is to have collaboration between us and defined collaborators. But things at GitHub allow us to collaborate with almost anybody around the world who comes along and looks at the repository and sees this is something which I want to work with, or this is something which would be useful for me, but I want to add some new feature. So in the past, and to some extent still nowadays, people's approach to distributing software might be that you write a paper, you do some analysis in this paper, and then you store you have your software, and you say the code to reproduce these results is available upon application. I suspect we've all encountered a paper like this, and you are invited to email somebody whose email address may have changed, they may have stopped working in the field, whatever. It's kind of frustrating, and you end up finding yourself just not doing it. Tools like Git allow us to store the code on GitHub in a place where people can see what the code is, what it does, which is better for science in general. I mean, it is always good to be open with how your methods work where possible. And you can also connect up your GitHub account to work with things like Figshare and Zenodo so that versions of your code are specifically stored with digital object identifiers, DOIs, which are citable. So specific versions of that code are citable, and then they are archived in a place where people can get them. So you aren't having to deal with being sent email requests for your code all of the time, and other people are able to access it when they want. So really, I suggest just having a quick glance through the remainder of the sections in this lesson, which talk about this kind of accessible, citable science. And then we are into the last 5 minutes. I'm not going to talk through all of this. I think you are all probably capable of having a read of it yourself. I was going to ask before we finish up, does anybody have any questions which haven't been answered so far in the chat? I've been keeping an eye on things and I don't think I've seen anything, but if anybody has any more general questions about Git or existential questions about version control, I can try answer them quickly before we finish up. Okay, well, I don't see any hands or any questions appearing in the chat. So what I will say is we'll probably touch a bit on some of this stuff again next week. And so Software Carpentry have added some of these sections anew to this course in the last year or two, which is good. But the final section of this course was kind of designed to deal with some of these previous deficiencies. So we'll talk a little bit about licensing next week as well. And we'll probably try and get on to a little bit about citation, but it's still worth going and having a look at the remaining stuff here. Next week's session is kind of designed to tie things together a little bit, and it is on software engineering principles for scientists. So we'll talk a bit about how you can actually write better and more maintainable code, how you can try and strategies and tools which you can use to document your code and to improve the documentation of your code, as well as some of the practicalities like how you package up your code to make it easier for people to install, as well as to access through things like GitHub. So that will be at the same time next week, so starting at 10 a.m. next Friday. We will principally talk about Python during that session. I appreciate not everybody's going to be a major Python user. It's designed in such a way that you should be able to carry across what you learn in it from Python to other languages, but you may need to use very slightly different tools. But it really is designed as a kind of very quick tour of all of the things which you should be doing, and to give you a kind of a jumping off point for going off and learning about how to do the things specifically for yourself. And unfortunately, 3 hours is just isn't really going to give us a chance to do much more than that. It's the final session is feels a bit more, I think, like a lecture than the three up until now maybe have, and there are slides for it in contrast to these previous ones, but hopefully it will be useful. All right, thanks everybody for coming today, and I think the video for the last 2 weeks, the videos for the last 2 weeks are now on the SUPA Moodle. If they're not, I will sort that out this afternoon, and this session should be online as soon as I can get it uploaded as well. So thanks everyone, and I will see you next week.